Okay, good evening, everyone. Let me start with the class. So today's topic is important from the perspective of the autonomous board of CBSE, and the topic which I have chosen today for discussion is space exploration. Now, as soon as this topic comes into my mind, space exploration, what happens is this is a very vast topic, and we need to rest, restrict our discussions only to the relevant portions of the syllabus, because space exploration, for that matter, because the level at which it is happening in India right now is something very vast. And you all know that we have space exploration for the we have reached Mars, we have reached um, we reached Moon long back. We have reached Mars, and as far as communication and weather satellites and other types of satellites which are to be considered, we are at very advanced level. So my discussion would primarily be focused on portions relevant to the syllabus of autonomous board, and I would not like to digress much from the topic or the syllabus. So the objective of this session is to prepare you for your board examination, and hence the complete focus would be on covering all the topics which are relevant to your board examination and which have been covered in your book. So let me start with the introduction. So I mean, if we look at space exploration, history of space exploration goes back to nearly 1500 2000 years back. But let's not get into that space altogether. We all should restrict ourselves to post independence development in the space exploration design of India. And what happened is that in early 1960s, after independence in early 1960s, Indian space program was founded. And why it was founded? Because the Tokyo Olympics was live telecast in most of the Pacific region, including USA, live for the very first time. And this inspired the Indian scientists, specifically Vikram Sarabhai. So late Dr. Vikram Sarabhai is the founding father of Indian space program. And looking at the developments in the space research world at that point of time, Indian government set up Indian National Committee for Space Research. It was set up in Tiruvananthapuram, and the work kept on going on. Later on, it was decided that we need program in space research which focus on space technology. We also decided, because 1960s 1970s, the early days of India after independence, was marred by several natural calamities including drought and flooding. So at that point of time, it was decided that we should have a space program which would be focused on different national needs, and to take that perspective into picture, and to overcome hurdles to which mars our progress in relief activities after natural calamities. It was decided that, and not only national calamities, other objectives were also there, like exploring space. So we also plan to go on moon, which happened sometimes later. So Indian Space Research Organization was set up in 1969, and with setting up of Indian Space Research Organization, India started formally in the sector of space research, and started developing technologies in the field of space program. Now, this was a brief history about Indian space program. Now, I will come to the history portion, and I'll come to what India is currently doing in space research right now. Uh, but it is very important to discuss in the beginning is what happens in a space program. So basically what we do is that we send some kind of satellite in the orbit of the earth, and that orbit does certain required works. It is designated to do some work, and like one job can be defined as to retransmitting the signal. So it gets signal from the earth, and it retransmits it over a large geography. The second can be taking photographs. So we see time and again, we see that suppose somewhere flooding has happened or somewhere drought has happened, and we see pictures from the sky that how flooding has affected the area. So photography, or for that matter, we recently 3 years back in 2015 we sent our 2014 15 we sent our first moon mission, which is named as Mangalyaan, which is in the orbit of Mars, and which is trying to study the characteristics of Mars atmosphere, and the other parameters related to Mars. So finally, what happens is there are two things which are required, and those two things are: first is launch vehicle, and second one is load. So load is generally your satellite. So what is an artificial satellite? So we all know that sun has earth has one natural satellite. So we have a solar system. Whatever revolves around the sun is known as planet. Now there are celestial bodies which roam around these planets also, or which revolves around these planets also. So revolving of a celestial body, natural celestial body, around any planet is known as a satellite. So like moon is a natural satellite of earth. Now when we send man-made constantly revolving objects around earth, They are called artificial satellites. So artificial satellite means man-made, continuously revolving bodies which revolves around the earth. Now that's what I have explained here. Space aircraft designed to revolve around the earth in a fixed path. Now they are characterized by three different parameters. And what are those three different parameters? So first is apogee. So let me make, suppose this is the earth and there is a satellite which is traveling like this around the earth. So this is the satellite's orbit. Now satellite orbit can be, has three parameters. First parameter is known as apogee. Now what is apogee? Apogee is a point in satellite's orbits farthest from the earth's surface. So whichever point in this satellite's orbit is the farthest far, or the at the most possible distance from the earth's surface, that is known as apogee. Now what is perigee? Perigee is the point in satellite's orbit closest to the earth's surface. So apogee and perigee are anonymous to antonyms of each other, and apogee is farthest point from the earth's surface, and perigee is closest point from the earth's surface. And where these points are taken? These points are taken on satellites orbit. Now what is inclination? Inclination is angle between the plane of the satellite's orbit and plane of the earth's equator. So this is the equator, 0 degree. So whatever angle this satellite orbit is making with the plane of the equator, that angle is known as inclination of the orbit. So if suppose there is one orbit of satellite like this, which makes 30-degree angle with this equator, the inclination of that satellite would be 30-degree. And from which point? The reference point. You always remember the reference point is not axis of rotation. Reference point for I have seen many a times that for inclination of satellites orbit, people take or get confused with uh, axis of rotation of earth. No, it is not the case. Reference is not axis of rotation of earth. Reference is plane of equator. So from plane of equator, whatever angle is made by satellites orbit, that angle is known as inclination. So this was a brief discussion about different points on the satellite's orbit. Now what we will do is we'll go to next slide and we'll try to know that how a satellite is put into orbit. So what happens? Try to understand. It is an example of projectile motion. And what is projectile motion? So try to understand. If I throw something like this, what will happen? It will go at certain height and then return back to the earth's surface. Why? Because it has been thrown at certain angle from the earth's surface. Now similarly, what happens? Suppose you have earth's surface here, and from a certain height over here we throw something like this. Now try to understand why this particular object comes back to Earth. Because there is certain force acting on this object in the direction towards Earth's surface. And what is that force called? Gravitational force. So what happens is, even if you are standing here and you throw a stone horizontally, after some time the stone will fall on the Earth's surface. Why does it fall on the Earth's surface? Because there is a gravitational force acting downwards on the object, which brings it back again to the ground. Now it will happen, like suppose I take this point as A and this point as X. So what happens is, if I throw something in X direction and if there is no gravitation, so it will keep on going in this direction always, this parallel direction always. But this is not the case. What happens is, as soon as I throw something like this will start moving like this and will fall on the Earth's surface somewhere here. Now, why this is happening? Because a force of gravitation is continuously acting on something being thrown from the Earth's surface. One thing which has been seen over here is that if we increase the speed of this projectile means something which is an object which is thrown or which is taken in the projectile motion. So if we throw this projectile with larger speed, this range, or range means where it is striking the Earth's surface, so this range keeps on increasing. So more the velocity, more the range. So if I say that this is the initial velocity v1, initial velocity v2, initial velocity v3, I can write that v3, I'm writing I also, so that I understand that I'm talking about projectile velocity or initial velocity. v2I greater than v1I. So looking this particular phenomenon into picture, what we can assume is that, or what we can find out is that, if we throw a projectile with such a high speed that it comes back again to this particular position, what will happen is it will keep on moving around the Earth with that velocity always. So that is how a projectile is put into an orbit. So how a projectile is put into an orbit? So for a particular speed of projection, what happens is the curvature of the projectile path will match the curvature of the Earth's surface. What I mean by this sentence is that for a certain speed, what will happen is, if I throw something from here, the complete curvature, because it is following a curvy path, I'm calling this complete distance as curvature. So curvature of this projectile would be equal to curvature of the Earth's surface. And due to that, what will happen is projectile will keep on traveling parallel to the Earth's surface like this. And this height would be a fixed height. And this is what I mean when I launch a satellite. When I launch a satellite, what I want is continuous motion above a certain height around the Earth continuously. For that, what I need concept of projectile motion. I need to calculate the specific velocity by which I need to throw this projectile, so that the curvature of this projectile becomes equal to the curvature of Earth's surface at certain height. And due to that, what will happen? It will continuously keep on roaming in that orbit around the Earth. So I hope you understood how a satellite is projected in an orbit. Now let me move to another topic, which is different types of orbit. So what do I mean by different types of orbit? So different types of orbit means at what height from the Earth's surface it is categorized as per the height above the Earth's surface. it has been projected. So depending on the height above the Earth's surface, we will have different kind of orbits. Now, why do we need different? Why can't we put all the satellites at one height? Because the usage of data from those satellite is different. I want photography from the satellite. I need to have different height for the photography. If I take the satellite far too above the Earth's surface, the photographs would not be clear. The photographs would not give me clear picture of what is happening on the ground, and it will be blur, so it will be difficult for me to fulfill my purpose. Suppose I want to find out the extent of drought, and the satellite is some 150,000 or 40,000 kilometers above the Earth's surface. The pictures taken from there of the Earth's surface would be blur and would not give me the exact data of drought. So that is why I need different heights of the satellite. If I need a communication satellite, for that matter, if I want a satellite which can throw the TV signals to the Earth's surface, I want it to be at more height than a photography satellite. Why I want a TV signal satellite to be at more height? Because I want it to cover a higher or a larger geographical area. So depending on the usage of the data from the satellite, the height of the satellite varies, and depending on the height of the satellite, we define the orbit of the satellite. So I think I'm making it clear. So what happens? So on height, different types of satellites are satellite type 1, 2, 3 are decided. I have mentioned here. I'll come to these points and why these different sites are needed. Because usage of data from satellite is different. Now, what are the different satellites? So before I discuss about types of orbit, let me discuss about footprint. Now, what is footprint? So let me define footprint for you. The area of the Earth covered by the signals from a satellite, or the area of Earth covered by the cameras of the satellite, is called footprint. So what is it? Area of Earth covered by signals of satellite or camera of satellite, that is known as footprint. So what is footprint? Extent of geography covered by signal or camera of the satellite. That is known as footprint of the satellite. So I have discussed this. Now let me move to something which is very important, the types of satellite. How many types of satellites? How many types of orbits? So different types of orbits I have mentioned here. The first one is geostationary. So what do I mean by geostationary? Is the satellite stationary? No, satellite is not a stationary. Satellite means it is continuously revolving around the Earth. But why stationary word has been used here? So geo, as we all know, is Earth, and stationary means with respect to Earth. The satellite is stationary. So what does it mean? It means that the velocity of both of them has to be equal. Then only with respect to them, they will be stationary to each other. So what do I mean by, just give me a moment. What do I mean by geostationary satellite? So geostationary satellites ensure that its footprints covers a given country or area at all the time. So what happens is, suppose I have to transmit TV signals, radio signals. How does a country ensure that its TV signal is not processed to any other country? By restricting the footprint of satellite. And how it is possible? So it is possible because there is a special circular path around the earth in which satellite can move and still appear stationary to the earth. Now how it is possible? So this is possible because this orbit is in equatorial plane of the earth. So this orbit, geostationary orbit, one important point is it is in equatorial plane of the earth. And due to it being in equatorial plane of the earth, what happens is the time period of the satellite, which is to take one rotation around the earth of satellite, is 23 hours 56 minutes and 4.09 seconds. And what is this time? This time is also the time taken by the direction of the earth's rotation around its axis. So what happens is earth is rotating around its axis in every 23 hours 56 minutes and 4.09 seconds, and at a height of 59,790 kilometer in equatorial plane of earth, there is a satellite moving which also has a time period of 23 hours 56 minutes and 4.09 seconds, which tells me that the speed of the earth and the speed of the satellite is zero with respect to each other, nearly zero with respect to each other. Hence the satellite would be stationary with respect to earth. So why it is kept stationary? Because I don't want the signals to transmit to any other place. If the orbit, if the satellite is here and it is not stationary with respect to earth, so what will happen? Now India is here and it is moving like this. I want the signals to be in India, and satellite is sending signals toward India, but because of the earth rotation, some other country will fall in the direction of the signal sent by this particular satellite, and it will not serve the purpose of, or suppose if it is not geostationary, sometimes it will happen that we will have signals, TV signals of other country, radio signals of any other country. So that is why this is kept in geostationary position, because the footprint of the satellites has to be constant at a certain geographical part of the earth. So I hope you understood the concept of geostationary orbits. Geostationary orbits are those orbits, is that orbit which is stationary with respect to earth. It means that both earth and the satellite's rotation speed is same, 23 hours 56 minutes and 4.09 seconds. It is possible in equatorial plane of the earth, which is 35,790 kilometers above the earth's surface. Now what kind of satellites are used? So this is primarily used for communication satellites. So why communication satellites? Because footprints needs to be restricted to certain geographies only. So I have explained geostationary satellites for you. Now let me move to the other type of satellite, which is polar satellite. Polar satellite. Okay, so now let me move to polar satellites. Okay, so what is a polar satellite and why it has been named polar satellite? So first of all, I told that the height varies. When I was discussing that why different type of orbits are used, so I told that geostationary satellites are, once again, geostationary satellites are also called geosynchronous satellites. This I missed when I was discussing geostationary. So height was 35,790 kilometers. Here the height is only 100 to 200 kilometers. Now what is the usage of it? So usage of it, certain applications of polar satellites are photographing, and that is why they are relatively closer to the earth's surface, because as closer the satellite to the earth's surface, better is the picture quality. Now where are these orbits possible? Such orbits are also called low earth orbits, and this is called polar orbit because what happens is this orbit is like this. Let me make a diagram for you. So orbit is just like this. So what happens? How does the satellite moves? Satellite moves from north to south. Now, how does geostationary satellite moves? As it is copying the Earth's motion, and Earth always moves from west to east. The geostationary satellites move from west to east. Now, these are polar satellites which cover the polar area. I told that this is I have already explained that it is in equatorial plane. This is in polar plane, so that is why this covers polar area. That is why this is known as polar satellites. Now what happens is these polar satellites, as they are not at very higher heights, what happens is their time period is not more than 90 to 100 minutes. So as their time period is 90 to 100 minutes, they travel many times a day around the earth, many times a day. So what is the uses? These satellites are not good for transmitting communication waves. Why? Because first of all, these are not stationary, hence their, if they are not stationary, their footprints cannot be controlled properly. Also, the signaling will not be restricted to a proper area, because being close to earth, they cover a very small region at an instant. So what will happen if it is at very low height? So first is control of footprint. If somebody is asking you why a polar satellite cannot be used for communication purpose, you need to write these 2 points, which is controlling the footprint, not easy. Second, they cover very small area. So these are the two reasons that we need to write. Now, where these satellites are used? These satellites are used for remote sensing purposes. Now, there was a movie. Let me take a real life example, and we all connect to movies and we all watch movies. There was a Hindi movie which just came 6 months back, and in which the Pokhran nuclear tests were shown in that movie. And the crux of the movie was that we tried to hide our nuclear programs from the satellites um, of USA. So what happened is that every day 2 to 3 times USA satellites were above our Pokhran range. They used to click pictures and they send it to the US Space Research Center, which is called as NASA. So scientists sitting in NASA were able to view those pictures and were able to know what is going on in that region. And that is why all our program was designed in such a manner that it only happened when the satellites were not watching us, specifically in the night period. So that is what one purpose of remote sensing is. If you see the kind of progress most of the developed and developing countries like India and China are making in the space program, one of the reasons for that is to take care of, or to keep an eye on enemy territory, that what an enemy is doing. You might have heard of surgical strikes, and there were news that those surgical strikes were the destination of the terrorists were captured by the satellites used by India. So that is what remote sensing means, that you don't go to any place, but you find out what exactly is happening by the pictures clicked by those satellites. So these satellites, polar orbit satellites, are used for remote sensing, for photography purposes, so that we can come to know that what is exactly happening in the areas which either we cannot go, or which are very difficult terrains. Like if I need to find out what is happening in Amazon, uh, Amazon, not the Amazon forest, and terrain is very difficult, remote sensing satellites can be useful there. Now let me move to another type of satellite, which is sun-synchronous orbits. So what do I mean by sun-synchronous orbits? So these are a special type of, first of all, it is a type of polar orbit. I have already explained what a polar orbit is. North to south movement. I'm again repeating it. North to south movement. Then second point is in polar plane. Third is 100 to 200 kilometers height. Now, what is the meaning of this special sun synchronous orbit? So, special sun synchronous orbit means, try to understand, I need to locate one particular region at the same time in the day or in the night. So, suppose I need to take a picture of one place, suppose Himalaya. Suppose I am trying to measure depletion of Himalayan ice or Himalayan glacier, melting of Himalayan glacier, and I need to take a picture daily at 2 o'clock or 2 p.m. How will I do that? So it's not necessary that these polar orbits that we were discussing would be at same place at same time every day. It's not necessary. For a satellite to be at same place at same time every day, they need to be in specific orbit, which is known as sun synchronous orbit. So first meaning of sun synchronous orbit is they are at same location above earth surface every day at same time. And how does it happen? It happens with the help of Sun-synchronous orbit. So it's a special type of polar orbit in which satellite passes over latitude at the same local time every day. So I have taken latitude means what? Latitude means horizontally we try to divide the Earth's surface. This is your equator, and at interval of 1 degree we will have several latitudes. So at same latitude, the same satellite would be there at the same local time every day. And what is the benefit of this happening? That we can click pictures of the same place at same time every day, and then we can use those pictures for comparing what is going around at the same time on 2 different days at that specific location. So what happens is, as I defined that, Sun-synchronous orbit is a special type of polar orbit in which satellite passes over latitude at the same local time, and it happens on a daily basis. So what happens is that you will feel like it will appear over a given place on consecutive days when the position of the sun over the place is the same. So looking at the position of the sun at a given geographical area, if the position of the same is same at this geographical area at the same time, this particular stationary sun synchronous orbit would be revolving around that particular place. So what is the benefits of it? The advantage of sun synchronous orbit is that, as I was discussing, photographs of a particular region taken by the satellites in its various passes over that region over a number of days are taken. And what happens is the light condition remains same. So if the light condition remains same, it helps in comparative studies, and comparative studies over a span of time. So for that matter, it can be used in understanding weather condition, global warming condition, the temperature. If I'm taking, see, I find out the temperature today it is -1 degree Celsius, and next day it becomes 3 degrees Celsius, and heat is more, or pollution is more, or something like that. And then what is the effect happening? How the glacier is being melting, and all those things. These things are possible with sun synchronous orbit. So I have discussed different type of orbits with you. I will again revise these orbits for you so that you have a clearer picture. So first one was your geostationary orbit. So I told that geo means Earth, stationary means stationary with respect to Earth, not. So it was possible because the Earth was, the satellite was moving in plane of equator at a height of 35,790 kilometers. And the time taken was 23 hours, 56 minutes and 4.09 seconds, which is actually equal to the time taken by Earth to rotate once around its axis. So hence, as the speed being same for the satellite and the Earth, they remain constant with respect to each other. And hence, what happens is the satellite looks stationary above a particular point above the Earth. So what I mean is that at that particular point, it will be easier for me, or with geostationary satellites, it would be easier for me to control the footprints of the satellite. So I can send my communication signals to desired place easily. And that is why geostationary satellites are used for communication purposes, so that the footprints can be restricted to certain geographies. Then we come to polar orbits, and polar orbits are in the plane of poles, and they are not at very larger height. They are not more than 100 to 200 kilometers away from the Earth's surface, And why they have been kept so closer to Earth's surface? Because these polar satellites are used basically for photographic and remote sensing purposes. And uh, the idea behind polar orbits is that it keeps on revolving around Earth so many times, so that taking different pictures at different point of time is possible. Now what happens is, the disadvantage of this kind of satellite is it cannot be used for communication purpose. And why it cannot be used for communication purpose is that the first point that I discussed was that the transmission of signals will not be cannot be controlled here, because they at different point of time they are at different position. Hence, I want to send a signal to Indian territory, but the other country would be directed towards the signals being sent from the orbit. So controlling that footprint of the satellite would not be easy. And second thing is, because it is at very less height, it will cover a very small geographical area. Hence, polar orbits are not used for sending satellites used for communication purpose. They are only used for satellites which go there for photography uh, and remote sensing purposes. Now, next satellite is Sun-Synchronous Satellites, and I discussed that Sun-Synchronous Satellite is a special type of polar orbit. And why we need Sun-Synchronous Orbit is that what we want is that above a certain geographical location, depending on the position of the Earth, the satellite in this orbit will keep on taking pictures, or will keep on sending signals at same time every day. So what happens is, this satellite passes over the same latitude at the same local time every day. And due to this, basically it is used for remote sensing purposes. And due to this, what happens is, I can take pictures of one particular location over a span of time, and I can do the comparative study of those pictures to find out how a certain phenomenon is affecting that place. Now let me move to applications of satellite. So first one is communication satellites. So what do I mean by communication satellites? Used for transmitting transmitting communication signals. Communication signals. So look at here. So what is the orbit? Orbit in which it is sent is geostationary orbit. As I already discussed, larger area for coverage and better direction of footprints. Now let's try to understand that water. First of all, you might not be knowing what communication signals. So communication signals, TV signals, then your radio signals, phone signals, mobile signals, your telecommunication, I should write. So these are all types of communication signals. Now what happens is that signals are sent from the Earth to this satellite. This satellite captures it through one of the devices called transponder. So transponder receives the signal from the Earth and then retransmit it. So what happens is the use of transponder in case of uh, communication satellite is a use of transponder is to receive the signal and then retransmit it. Now these retransmitted signals are received at the ground level. Now what happens, because it is traveling a certain distance, they become quite weak. The signals becomes quite weak and they are amplified by the receiving machines at the ground level. So what is the application? The first application I am discussing is application satellite for communication. In satellite for communication, they are placed in geostationary orbit. Why they are placed in geostationary orbit? Because we need a better coverage and better management of footprints, and then for that we are using a transponder in the satellites which receives the signals and resend it to the Earth, where where it is received at a very weak level, and then it is amplified and sent back again. And what happens is these satellites are, or these communications are coded in form of electromagnetic waves. Now electromagnetic wave, few examples are light waves and all these things. But what happens, electromagnetic waves are characterized by different energy levels. So the lambda of these electromagnetic waves, the wavelength of these electromagnetic waves is quite higher as compared to lambda of light. So these points you need to remember in case of satellite for communication. First, you need to write that they need to be in geostationary orbit. Then you need to write that. Then you need to explain a little bit that why they are in geostationary orbit. I already covered it. Then you need to go that how these are. This point should come that how the signals are received by these satellites. So you need to mention the word transponder. If you don't mention the word transponder, your marks would be deducted. So you need to mention the word transponder. Then you need to say that this is used for receiving the signal and then retransmitting it. Then you need to say that the signals are then sent back to the ground level where it becomes pretty weak, and then it is amplified and sent back to the adequate positions. And then you need to say that these are electromagnetic waves. So the communications which are sent on the ground level are coded in electromagnetic wave format. You also need to say that the lambda or the wavelength of these electromagnetic waves are higher than that of light. So that's how you need to write this answer. These points has to be there in your answer. If it is not there, marks would be deducted. Now let me go to another example. So one second. One thing which I did not cover is what are the India's advancement in this segment. So India's has just on December 19, 2018, India sent a satellite for communication purpose, which is named as GSAT 7A. and the launch vehicle was GSLV. So India has sent a lot of satellites. In your book, if you will see, it has been mentioned as INSAT. Initially, INSAT satellites were sent. Now India has progressed to altogether different levels. So initially, INSAT satellites were sent. Now we have moved to G, GSAT. So full form of INSAT is Indian National Satellite. Just write it down. Indian National Satellite System. So if you look at the progress of India in communication satellite launch, INSAT is very old form. Now GSAT, what is the full form? These are geosynchronous satellites. I also told that geostationary satellites only are known as geosynchronous satellites. So GSAT is geosynchronous satellites, INSAT is Indian National Satellite System. If you look at the INSAT satellites, last INSAT satellite, which was INSAT satellite 4CR, which was sent on September 2007. So after that, no INSAT satellite has been used, only GSAT satellites has been used. We sent GSAT 7A satellite just recently on December 19th. Now, the launch vehicle which is used for sending these satellites are known as GSLV. What is the full form of GSLV? Geosynchronous Launch Vehicle. So satellite means geosynchronous satellite launch vehicle. So I have not written satellite here. Always remember that wherever you hear the name of SLV, you should understand that SLV full form is Satellite Launch Vehicle. So this is SLV. Now, in case of geosynchronous or geostationary orbit, we used G so that it can make it clear that which orbit the satellite is going to. So G means it is going to, the satellite launch vehicle is taking it to geostationary orbit. So INSAT full form, which is there in your book, I have covered. It is Indian National Satellite System. We have moved ahead from INSAT satellites to GSAT satellites, which are geosynchronous satellites, and the launch vehicles have moved to GSLV, which is known as geostationary or geosynchronous satellite launch vehicle. So this is the relevant information for communication. If you write a few lines about GSAT and INSAT, you can write that initially we used to use INSAT satellites. We still are using, but we are not projecting them now. We are now sending GSAT satellites with the help of GSLV vehicles. Now, let me go to the other type of satellites, which are your weather satellites. Now, what do I mean by weather satellites? So weather satellites, as the name suggests, is used for weather monitoring. So how do we always know that, or if a storm is last 3-4 years, every year we see that on the eastern coast of India there is some kind of storm, and before the storm approaches our coastline, 2 to 3 days before it only, or minimum 24 hours before the storm strikes the coastline of India, we are we start preparing for that storm, so that it does not affect, if it does not affect the livelihood of Indians, and we try to protect our citizens, we try to protect as many things as possible. Now, weather monitoring satellites are known as INSAT satellites. So INSAT satellites are used for weather monitoring. They are also projected by ISRO. The specific use of weather monitoring satellite is to monitor weather, so rain pattern, storms, or any other particular phenomenon, natural phenomenon. So in case of weather satellite, you just need to write that weather satellites, usage of weather satellites. What are the usage of weather satellites? You can say that rain, thunderstorms, cyclones, droughts. These satellites are used to collect information about various factors in atmosphere at various altitudes. So India currently is using INSAT satellite for this purpose. And what is the usage of it? Why it is important? Because it helps us to minimize the loss of life and property. So if you write these 3-4 points, this should be enough for your answer. You don't need to write too many things in this particular heading. Now let me move to remote sensing. So what do I mean by remote sensing? So see here, I have written remote sensing orbits. So I will discuss about these IRS-1A and IRS-1B everything later. Let me first tell you what do I mean by remote sensing. Though I have already covered this, collecting information of certain areas without actually going there. So what happens is, I have a satellite and I want to know that what is going on in an enemy territory. So suppose a terrorist location is there, which I know that these terrorists are lethal for my armed forces and general public. So I need to monitor these terrorist location and their activities over there. So I have my satellite, which what does it do is that it will always pass over this particular area of the earth at approximately same local time. So which type of orbit I'm talking about? Sun synchronous orbits. So what happens is, a remote sensing satellite cannot be stationary at one place. Can't be stationary at one place. In this kind of satellite, what I want is that it should cover a very vast area of the earth through its journey. And what does it do? When it covers a vast area, it keeps on taking photographs. And takes photographs of different regions and send it back to the receiving stations. Now the good thing is that as it is in Sun synchronous orbit, the illumination level is same always. Hence, it helps in comparative studies. So different type of orbits which I have discussed with you just right now has different uses. So what happens is, for remote sensing satellites, we use sun-synchronous orbits, which keeps on um, moving around places here and there. And then we take photographs, and with the help of photographs, we do um, comparative study of one place, and try to find out a pattern in the activity, or if certain things are happening. The first thing is this one, IRS, Indian Remote Sensing Satellite 1 A, was launched in 1991. And this IRS 1A, and we took help of Russia in trying to project it. Now, what are the benefits of it? So it gives information about, first, agriculture, then geology, forestry, hydrology. All these are uses of remote sensing. Hydrology means you can understand river, flood, all these things. Geology means your normal, so you can keep drought over here. Then forestry, you have a forest region, suppose a forest fire is there or something like that, and you want to find out something. Agriculture, how do we come to know that how much paddy and how much hectares and all those things. So agriculture for that. So these are these are the different uses of Indian remote sensing satellites. So I have already mentioned that they are in sun synchronous orbits, keep on rotating, take picture of one place at same time every day, and that can be used for comparative studies. And then you have to write these things. So if you write these things, your answer becomes complete, and then you get full marks. If you leave anything, don't forget to mention IRS 1A and 1B, Indian Remote Sensing Satellite 1A and 1B. Now you have the other use of or other application of satellites, which are collecting information about planets and outer space. So I told you that moon, or let's say Mangalyaan was launched for Mars mission. USA and USA Space Agency, which is NASA, it keeps on sending different um, satellites for studying different planets and different asteroids and meteors and all those things. So the usage of this kind of satellites is that we keep on discussing we keep on finding out photographs of different satellites and planets and asteroids, meteors, so that we can find out the atmospheric pattern of those celestial bodies. We can find out what kind of rock which has been used there. Is there any air? Is there any water? Is there some kind of growth of organism over there, or is it good for human being? Can human being go and stay there? So we, these kind of probes and studies keep on happening with the help of satellites, which are used for studying outer planets and outer space. Now I have already discussed launch vehicles with you. Let me specifically discuss launch vehicles over here. So I have mentioned two specific launch vehicles: PSLVs, Polar Satellite Launch Vehicle, and GSLV is Geosynchronous Satellite Launch Vehicle. Now, as the name suggests, polar and geosynchronous satellites are used for sending satellites into different orbits. Polar satellite sends the satellites into polar orbits, and geosynchronous will send it to geostationary orbits. Now we know that first thing to discuss over here is, we know that polar orbits are 100 to 200 kilometers away from here. So hence the thrust required would be less, because this is 35,790 kilometers. So which is nearly 300 times or 350 times, 360 times more than and this. So thrust required for GSLV satellites are more than the thrust required, or the force required to send it is more for this. So what happens for geostationary satellites is that for too many years we were not self-sufficient, because we were not able to develop the kind of rockets which were able to provide that kind of thrust, which can take our satellites to geostationary orbits. But we have been self-sufficient in PSLV system for last more than 15-20 years, and we have been doing it indigenously here in India only. Now, if I talk about PSLV systems in India, we have also started uh, uh, taking satellites of other countries, and it has become a very much a profit making venture for ISRO. So we are self sufficient in PSLV. We are almost self sufficient in GSLV. What happens is, now as we have uh, launched GSLV 7A, sorry, GSAT 7A, as I was discussing some time ago, that was launched from India itself. So we are self-sufficient in both the technologies now. Now let me go to another topic, which is, let me just go to another topic. So one thing which is very specifically mentioned and which we need to study is that what makes requirements for self-sufficient self-sufficiency in satellite technology. One is fabrication of satellite. So what do I mean by before fabrication? We need to plan the satellite, then we need to design the satellite once the plan is done, and then fabrication is required. Once we design it, we need to make the hardwares of the satellite. We need to install equipments, we need to install different electronic devices, we need to do the wiring, and then we need to seal it properly. So each satellite has to be designed according to the purpose, and then proper planning before it is required. And once this has been done, then we should have the basic infrastructure to fabricate different parts. So it requires very high degree of precision. And it's the most important, one of the most important part of launching a satellite. Then we need to have launch vehicles. So I have already discussed the launch vehicle, the two kind of launch vehicles. Now launch vehicle also needs to be fabricated. So there are two parts, as I discussed, mentioned in the beginning of the slide, is that we need to have a good uh, launch vehicle, and then we need to have a load. So load is your satellite, launch vehicle needs to be fabricated. We should have been we should have firing rockets at appropriate sites, which can take my load at the desired uh, in the desired orbit. So second thing which is important is launch vehicles. And by launch vehicle, what do I mean? I discussed about GSLV and PSLV. So what is required is fabrication, and before fabrication, what is required is rocket technology. Now we are discussing cryogenic engines and all those things, so that it can help, it can make the rockets volume smaller. We are also discussing different jets. One is Ramsar jet. So the purpose of those jets is that what happens is we spend a lot of money in making these rockets, and once they are fired, it's fire and forget kind of rocket. So once they are fired, those rockets cannot be, or those launch vehicles cannot be used again. So what ISRO is trying to do is that once the a rocket is used, and it has placed the satellite into its desired orbit, if we can get the rocket back, if we can get that launch vehicle back to us, we can use with certain modifications and with certain um, reno- um, renovations, we can use that satellite launch vehicle again, and this will help in decreasing the cost of ISRO. So these are the progresses which are going on in current scenario. The third one is earth control system. So what is it? So earth control system is two of them I have already discussed. The third one is and the earth control system is something like this. So suppose this is the earth and satellite has been moving in this orbit. Now how this satellite would be controlled? So all the operations of satellite is controlled from this earth control. So control of satellite in its orbit. The second thing is receiving messages sent by satellites. And then in control only, how do you control? By sending some commands to it. So command it, send some commands to it. And then what happens is, when a satellite is there and it is orbiting around the Earth, and it is in that space, there are so many different forces acting on the satellite. So uh, for an example, meteors are there, so bombardment of meteors. Then that satellite will have forces acting from different bodies like Earth, Sun, Moon. Then magnetic field is working over there, and due to that, what happens is, because of these different forces acting on satellite, the satellite can deviate from the orbit, which is not desired. So this Earth control systems keep a close watch on such deviations, and depending on the corrections needs to be done, it keeps on doing those corrections at time to time level, so that there is no fault which develops in the satellite which can deviate it from its orbit. So any fault which is generating due to different forces acting on satellite is rectified by or corrected by Earth control system. And if it is not possible, then we need to have a backup equipment. If backup is not there, suppose it is a very very important satellite from the perspective of navigation system or communication system, or for that matter um, remote sensing, and it has deviated from its orbit, and there is no backup available, then it becomes very difficult for that time. I mean, it's not a daily process that we launch a satellite, so we need to have a backup for that. So Earth control system is a very very important part of managing the satellites in the orbit. Specifically for communication satellites, what happens is, the Earth control system will control the position and orientation of the antenna on the satellite. So that what happens is, if I told that communication systems signals needs to be restricted in given geographic location, and if we don't change this position and orientation of antenna, so what will happen is signals will not be received at the desired location and will be wasted. So to reduce the malfunctioning of, or to reduce the chances of malfunctioning of communication satellites, the Earth control system will reconfigure the orientation and position of the satellite. So I have discussed several functioning of Earth control satellites. So node deviation, I have written two things: control of satellite, giving commands to it, receiving messages. Then node deviation due to external forces. Then what happens is, then if deviation is happening, so activating backups, then repositioning of antennas of communication satellites. So these are the things possible for Earth control system. The fourth one is, and the last one is, ground facility for utilizing satellite technology. And what do I mean by it? So what happens is, I told you previously that the signals are sent to transponder receives it in the satellites, and then it transmits it. This is gathered at, so why it is sent? Because see, what happens is, the ground level system cannot transmit this signal at various locations. Now when it is sent to sent to a satellite at certain height, so suppose this is Delhi, from Delhi perhaps it can send to some other places like Chandigarh and Lucknow. Suppose it is in Bangalore, so it can send to Mysore and all other places. But when it is sent to a satellite here, this satellite can send it to Bangalore and Mysore also, and Delhi and Jammu Kashmir also. Like our DD National, if the main antenna is main signal sending device is in Delhi, so I'm sorry, so that is sent to a space satellite in the orbit, and that is sent across the India. So what happens is, after retransmission of it, it has to be collected at different centers. So like if you look at here in Bangalore, you have a Akashvani house here, which receives the signal. Similarly, you will have the Doordarshan receiving system over here, and what it will do is it will capture the signals sent from the satellite. I said that once it is retransmitted, it becomes weak, so it can get amplified over here, and after amplification, it is sent to the nearby areas. So if these ground facilities which receives the retransmitted signals from the satellites are not available, the benefits of the satellites would not be utilized by the large masses. So what happens is that for satellites to be, or for signals to be retransmitted to larger masses, these ground facilities are required. So these are the four things which are required to make any country self-sufficient in launching satellite. So first one was that you first make a satellite itself. So you do the planning, you do the design, and then you fabricate your satellite. Then you develop a launch vehicle. Then the launch vehicle need to have a required amount of thrust. For that, engines needs to be developed. So develop that engine. Once the engine is developed, then fabricate that satellite launch vehicles. After that, you need to have earth control system, which is actually controlling the satellite in its orbit, and protects it from deviations from different forces, and then keeps on reconfiguring its antenna so that its footprint can be managed properly. And then we need to have a facility which is known as ground facilities for utilizing the space technology. So like we have Doordarshan houses and Akashvani houses, which captures the satellites, captures the signals from the satellites, amplify it, and then transfer it to the larger masses, so that the benefits of these signals can be availed by people, and it can be utilized properly. Now, the last topic of today's discussion is space program in India. So space program in India uh, is primarily focused on benefiting the common man of India. So our space program is not for any war purpose or something like that. Whatever we do in space technology is for the benefit of common citizens of India, the common man of India. And the objective of this program is three pronged. So the first objective of the space program is that usage of satellite for communication and education. So first we use it for communication and education, and where? Specifically in rural areas. The second facility is survey and management of countries' natural resources. And then third is, to do these things, we need development of satellites and its launch vehicles. Because if this third objective is not fulfilled, the other two will become redundant and will not be of any use. So most of these objectives have been achieved by, to a larger extent, have been achieved by India. So we are using our own communication and television broadcasting, meteorology and disaster management, resource monitoring satellites. Also for remote sensing, we are using our indigenous satellites, which are developed and launched in India. Now, India is also planning to use its launch its man mission, in which India is planning to take 3 people to space in 2021. This has already been declared by the Indian Space Research Organization. One of the major achievements, if I talk about, I told you in the beginning that later I'll get into the history portion uh, the satellite systems in India, and I told that one of the major achievements was launching of Aryabhat. Now, what was Aryabhat? It's the name of the satellite which was for moon. So it was launched in 1975. The news is that we are also launching the Aryabhat 2 satellites for the moon mission, and it was supposed to be launched in October last year, but by some reason, for some reason, that was not able to happen. So we will see in the coming time that Aryabhat 2 would be getting launched for the moon mission. Some of the important satellite programs of India is Bhaskara series. The Bhaskara series is, this is very important. It is for remote sensing. Then we have Rohini series. Rohini series was also for remote sensing. So these were called experimental. Now we had stressed Rohini satellite series, and it was called SROS. This was for astronomical observations. Then we have our IRS series, which is Indian remote sensing satellites, which we are using now. You need to remember that Apple is Ariane passenger payload experiment. This was the first communication satellite launched by India, or launched by ISRO. And it was placed where? It was placed in geostationary orbit. Then we have our INSAT series. So in INSAT series, we have the INSAT series is used both for communication and weather forecasting. And now we have moved to GSAT series, which is also a communication satellite. So these are the things which are we need to remember. The always remember this. I've told you full form of all these things. INSAT is Indian National Satellite System. GSAT is Geosynchronous Satellites. Then PSLV is Polar Satellite Launch Vehicle. GSLV is Geosynchronous Satellite Vehicle. Then ISRO is Indian Space Research Organization. Apple is Ariane Passenger Payload Experiment. Remember these full forms. These full forms are asked on the very frequent basis. Now, one thing which is left out and which is the last thing is tracking of spacecraft. So what happens is once a satellite is launched, it needs to be continuously monitored. So this continuous monitoring of satellites after being launched in the orbit is known as tracking of the spacecraft. And for this, we have a ground controller tracking system which is able to know its position in the orbit. And I was discussing that in Earth control system, that Earth control system is nothing but to track the spacecraft in its orbit. So if there is any anomaly, if there is any particular fault which is coming inside the motion or inside the orbital motion of the satellite, it can be corrected from the Earth control system, or a backup can be made ready so that there is no disturbance in receiving of the signals. So I have explained most of the things which are relevant to your board examination. Any specific doubt from your side would always be appreciated. If you have any particular doubt, you can post it on our groups, and the answers would be given accordingly. So thank you so much for joining this session, and I hope I was able to cover most of the portions which are relevant to your portions in the board. If you have any doubt, do let us know. And thank you so much, and all the best from the Centum Academy. We wish you all the best, and perhaps your exam would be good. We are very sure about that. So thank you so much.